Hi, my name is Vipul Chavda and our team number is 41. So I will be presenting about the domain name system using distributed hash table. My teammates are Avni Gupta, Jalees, Meda, Pushkar, Shorja. So now coming on, what is the distributed hash table? A distributed hash table is a distributed system that provides a lookup similar to a hash table. Key value pairs are stored in a DHT and any participating node can effectively track the value associated with a given key. The main advantage of the DHT is that nodes can be added or removed with a minimum work around redistributing keys. Keys are unique identifiers which map to a particular value, which in turn can be anything from addresses to documents to arbitrary data. Responsibility for maintaining the mapping from key to value is distributed among the nodes in such a way that change in the set of participants cause a minimal amount of disruption. This allows a DHT to scale to extremely large number of nodes and to handle continual node arrival, departure and failures. DHT form an infrastructure that can be used to build more complex services such as Anycast, cooperative web caching, distributed file system, domain name services, instant messaging, multicast and also peer-to-peer file sharing and content delivery systems. Now, the DHT characteristically emphasizes on the following properties: autonomy and decentralization. The nodes collectively form the system without any central coordination. Fault tolerance. The system should be reliable even with nodes continuously joining, leaving and failing. Scalability. The system should be function effectively even with thousands or millions of nodes. Now, there are various implementations of the DHT, but for the current scope of the project, we have implemented two implementations. One is code-based algorithm, second is pastry. So, for code implementation, the code is a protocol and an algorithm for peer-to-peer distributed hash table. A distributed hash table stores key value pairs by assigning keys to different computer, also known as node. A node will store the values for all the keys for which it is responsible. Code specifies how keys are assigned to nodes and how a node can discover the value for a given key by locating the node responsible for that key. Code is one of the four originally distributed hash tables protocol along with CAN, Tapestry and Pastry. It was introduced in 2001 by Ion Stoica, Robert Morris, David Kager, Franz Kashok and Harry Balakrishnan and was developed at MIT. Now coming on the overview. So each node chooses an n-bit ID. The ID is distributed randomly and they are thought of a fixed hash info. IDs are arranged in a node. Each lookup key is also an n-bit ID. The hash of the real lookup key. Node IDs and key occupy the same space. Each node is responsible for storing key near its ID, traditionally between and previous node. Item is stored at successor and can be replaced at multiple successors. So now, continuing with the algorithm for finding successor. So we ask the n node for the successor of the ID. If the ID belongs to n2 successor, then we return that our next node is a successor. Otherwise, we pass this message around the circle and we pass it until we get the successor with the given ID. So we also make a search on a local table with the given ID and return that finger. So this every time when a node joins and departs, we need to stabilize our ring. So we continuously call a stabilize function periodically and fix fingers in the finger table accordingly if the new node added or has removed from the list. So now, what are the potential use cases of the DHT? So it could be DNS, it can be cooperative mirroring, and it can be time sharing storage, distributed indices, and also sometimes it is used in wireless sensor networks. So now talking about the constraints and complexities of the code algorithm. In the code algorithm, the number of routing steps taken are of order of log n because the message passes to the peer. And also if in an unstructured P2P network, the lookups of the message could be of order n. Now talking about the code implementation of the DST. In DST, multiple nodes join with each other to form a ring. All the nodes process the request based on the hash value of the key to be inserted. The node that received the request finds the appropriate node that will contain this key and perform the required operation. Here we have created a separate client and the server. The client by default sends the request to the first node and it automatically reroutes it to an appropriate node. The client is a Flask based web application and the server is a Flask based API. One of the server node receives the request and forward it to an appropriate node. Here I already have started the client. Now I will be spinning up the 4 instances of the same server at port 8080, 8081, 8082 and 8083. These nodes will choose 8080 as the parent node and will automatically balance them out to form a ring. So we can see all the 4 nodes are ready and they don't contain any value till now. So now loading the client. So for example, adding the google.com as the DNS record and the value will be of the IP address could be, for example, 10.23.45.89. So now the entry is added. Now getting back to the nodes. Here we can see it automatically reroute to the 4th node. Now adding one more record, for example yahoo.com. The IP address could be 55.78.98. Now we can see that it automatically rerouted yahoo.com to the second node based on its hash value, while all the nodes first node received the request for entering it. Now adding one more value, for example facebook.com. Here we can see the 4th node again received the request for facebook.com. So now trying to search it out. So for example, we haven't added twitter.com to the server. Now we will try searching twitter.com. See, we can see that the key was not present and it gave an appropriate message here. So now searching for the value for the facebook.com. So we got the result as 12.23.45.89, which was added to the record. Now trying out with deleting of any key. So for example, I want to delete google.com. After submitting, we see that it got deleted. Now searching on the 4th node, which already had it. The 4th node already was having the google.com, but now after deleting it, it is removed from the memory of the 4th node. Now when we try updating any node, for example facebook.com, facebook.com has currently 12.23.45.89 as the IP address, but now updating it to, let's say, 15.65.89.78. Now we can see the value of the IP address is updated to 15.65.89.78. In this way our DHT works.
So moving on to the demo for pastry, here we go. We have implemented the pastry DHT in Python and server and client using Pyro4 library. First of all, I'll run the instance of server. This is the server running with URI which is equal to this. Now I'll run the client. As you can see, the client gives us 4 options, which is enter nodes on new site, add more nodes to an existing site, route a node, or get routing table elements. First of all, I'm entering nodes on new site. Site, let's say google.com. Now, number of nodes, I'm entering 2 for now. Node ID, let's do it as x01. So this is basically hexadecimal format. IP 10.2.2.1 and port, let's give it as 8000. Now moving on to node ID 2. IP, I'll be giving some random IP and port. As you can see, the nodes got added to the routing table, and here are the elements of it. The first one is the hash and the corresponding node, hash and the corresponding node. So now let's add some more nodes to an existing site. Our site name is google.com. We can actually create multiple sites and then add multiple nodes to it. So for now, I'll be adding one more node, say with ID x03, IP as 10.8.8.8, and port as, let's give it as 6000. Now, as you can see, the routing table is updated. Now I'll actually go and route a node. Let's route the node we just added or some node before it. Let's add x03. As you can see, the node ID, this is the closest node followed by this and this. So here is the working of the pastry DHT. Thank you.